Action potentials are signals which trigger communication with surrounding cells. Before an action potential can be generated, the motor end plate or axon hillock must be excited. Action potentials are an all or none phenomenon, so if a stimulus is smaller than a certain threshold size, the signal merely dies out. If the stimulus is over the threshold, an action potential is generated. The action potential starts when voltage-gated sodium channels are opened and sodium pours into the cell. Within 1 millisecond, the membrane potential becomes positive and the sodium channels are closed by an inactivation gate. Until the membrane repolarizes, the cell is in the absolute refractory period. As the sodium channels become inactive, potassium channels open and potassium streams out of the axon. This outgoing potassium current repolarizes the cell, bringing it back to the resting potential. As the potential dips back to its resting value, the sodium channels switch from inactive to potentially active, meaning they can now be opened if a large enough stimulus triggers them. The cell is in its relative refractory period while the potassium channels remain open and the cell is hyperpolarized. Another action potential may be generated, but it will require a stronger trigger stimulus than the first.